We are back once again for Daily LeetCode, Day 74. We are back once again to write code using the greatest language ever created, Ruby. Confirmed. This is the final language. There will never be another language created that is better than Ruby, right? I was looking at some tests yesterday. It's faster than C, faster than C++, faster than Python, faster than WebAssembly. This is the greatest language ever created by man. Okay, the article I was referring to with tests is actually not true. I actually don't know how fast it is. It's just to say it's fun to write Ruby, right? Every language has its place. We have a legendary comment from Thomas Wong. Maybe I should switch and try a new language as well. Could be a new way to tackle problems. But we'll report back with results, right? It's hard to know, right? So I think at the end of the day, we're problem solvers, right? So if that's the case, I know the common thing I think is to use Python, right? Because it's like easy to do a lot of things in Python. You don't get lost too much in implementation sauce. But at the same time, I think it could also be used as a vehicle to practice new languages. So that could be cool. We got I'm Just That Guy, One Piece Luffy Admiral, mentioning quite an early upload today. I'm for it. Good morning, brother. I'm for it as well. It was the weekend, right? So we had some free time available. That was pretty cool. Today we are back once again. Yesterday we dunked on a problem called clone graph, right? In Ruby, the greatest language ever created by man. And we got to do a cool BFS on it. I didn't think we would actually solve it. The distinction between discovery and processing was pretty useful, pretty cool to see. This is ultimately a function of reading the Algorithm Design Manual by Scienna et al., legendary group of auteurs, also writers, algorithms, and computer science makers. So that was pretty cool. Also been doing some Ruby on Codecademy. So yeah, hoping to add another language to the tool set. But yeah, I think in a strange way, LeetCode problems kind of help you do a bit of a walk around the language. Obviously, we won't get to touch every single part of the language. You know, like I don't even know how Ruby handles asynchronicity, right? I don't know how it handles files. I don't even know if it can. I'm sure it can, right? But there's a lot of things we don't know. So that being the case, right, I think we do get a general walk around the language and having to use it, right, by sort of, messing with some of these problems. So that was pretty cool to see. It was cool to solve this problem. And yeah, ultimately our solution was sort of slow. But either way, it was still good enough, right? And so we got to see what needs to be done today. We have a long list of problems to do. Fortunately, right, we have the greatest tool ever created by man, Ruby, to do it. But I don't think I'm going to solve every problem in Ruby. We're going to switch between the two, right? But I've already solved them in JavaScript, so just doing them in Ruby is just another way to visualize the problem. Reflections on readings. I received a tip from the Copy Ninja himself mentioning Quaster. Now this seems to be a tool, right, or a newsletter that's going to send us engineering blogs from top tech companies about infrastructure, cloud, scaling, right, everything we want to know. And that's kind of like what we're doing with the system design that we try to do every day. We try to read a little bit about it, right? And Quaster just delivers you the summary, right, and the article itself. So that's pretty cool. So I signed up for that. It's free. I don't know if it's good or not, but if we're taking it from the Copy Ninja, we have a guarantee on quality. So we're going to be reading some of those. I've also been posting some stuff in the Discord about system design things that we're reading. And for some reason, whenever we put system design in the title, the video goes crazy. So I'm going to sneak system design into the title some way, right? The title is probably not going to make sense, but it is what it is. We got to play the game. Other reflections, I was looking back on some of the older videos on the channel. I'm going to be honest, until about 8 days ago, right, we kind of looked like a mad scientist with the beanie and the overgrown hair, and it was kind of fire. So we'll have to work back up to that level. We had a massive block of hair and the hat, right? So we're actually receiving a debuff currently, since we no longer have as much insulation, right? So you can imagine hair is like a tinfoil hat, right? And now my intellect is being sucked away by the atmosphere. So that being said, we're back once again. We're gonna do some problems. I see some here like linked list, cycle, number of provinces, and so on. That I don't really know how to use a class, right? Number of provinces is like a disjoint set or union find problem. I don't know how to make a class yet in Ruby, but there's also a BFS version we can also use to solve this. So we're just gonna go through and try to solve all these. To be honest, I'm gonna put 30 minutes on the clock today just because we don't have as much time. But sometimes you gotta walk so you can run, right? So we're leveling up on LeetCode problems, right? And as the Copy Ninja mentioned, right, we're leveling up heart health next. So get outside, get out there, run a mile, right? Get that heart rate up to your age 220 minus your age, right? So we can get our VO2 max up and we can live long, fruitful, hopefully fulfilling and healthy lives. So we're leveling up heart health next. So yeah, I did some running today and some working out. So that being said, my bar for LeetCode is a little bit shorter because I think it's all part of the same bar. So we're gonna do 30 minutes today, right? And then I actually still have to do, it's about 10 right now. I'm gonna do 30 minutes of LeetCode and I still have to do about another hour and a half of reading. So gotta balance all the buckets. So we're just gonna jump into it. Make sure to join the Hyperbolic Coding Coalition. This is a coalition or chamber. Maybe that is exchangeable. It is a coalition that is growing very, very quickly for coding and all things coding. Coding paraphernalia, computer science paraphernalia, coding articles, right? Objects and all sorts of things of interest. You're gonna wanna join to have access to these very important things. So make sure to join the Hyperbolic Coding Chamber. Lots of cool tips, system design and engineering articles in there, right? I'm also thinking maybe we'll do like a book club thing soon, but we'll see. Let me know if there's interest. And yeah, so we're just gonna jump into it. 30 minutes on the clock, daily LeetCode, day 74. So we have linked list cycle. I haven't done this problem in so long. We last did it on July 1st. So that's pretty cool. And we're in Ruby, right? I also got to make sure to shrink my camera. Right, there we go. I'm gonna make this a little bit bigger. My keyboard died. So now we're back. Given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, return true if there is a cycle in the linked list, otherwise return false. Right? So we're given a linked list and they want to figure out if there is a cycle or not. And the cycle just means if there is a node that we can visit again by continuously visiting the next pointer, right? And we have 3 of those such nodes, so there is a cycle, right? If we go from 3 to 2 to 0 to 4, then go next again, we're at 2, we already saw 2, right? So one way to do this right, and here we can see we can also be given 1 node. And is it possible that there's no nodes and it says yes, the number of nodes in the range is 0 to 10 to the 4. Can you solve it using constant memory? So just off the jump, right, if, my keyboard said, if head, right, so if not head, right, we're gonna wanna return, well, right, it's a good question to ask, right? If there's no node, is there a cycle? We'll just say false, right? And so to start, our output is null, right? Because we're not returning anything, right? So that's good. And so how can we tell if there's a cycle? We know that we can use the rabbit and turtle algorithm, right? Where we have a pointer, right? Which is going to be turtle that starts at 3 and rabbit, which starts at 2. And rabbit is going to move twice as fast as turtle, right? So if rabbit starts at 2, it's going to move twice to -4, and rabbit's going to move forward once to 2, right? then rabbit's going to move twice, right? From 2 to 0, right? And since turtle is here, it's going to move 1, and now rabbit and turtle are going to be the same. Since rabbit runs twice as fast as turtle, if there is ever a cycle, we know for certain that rabbit and turtle should pass each other at least once, right? Similar to if you're running on a university-style circular track, right? There's no way that you can finish the entire track without running into someone, right? Just because it's circular, right? But the only way, the track being circular is an ode or nod to the linked list having a cycle, right? If there is no cycle, right, then the university style track would just be a regular stretch, right? A sprint, right? If there's no cycle, then if the rabbit runs really fast, he should just cross he or she should just cross the finish line and they should be done, right? So that's kind of the intuition we'll use for this, right? And so what we can do is say rabbit will be equal to head, and turtle, oops, I messed up. Turtle will be equal to head, rabbit will be equal to head dot next. And we know that dot next exists because of these things here, right? These two properties here, right? And we know that at least head exists, right? So we know that there's no, we know that at least head exists, right? Because we would exit otherwise. So if we make it past 15, we know it exists. And so what we're going to do is we can either do loop do, or we'll just say while, right? And so how do we know we want to continue, right? So if rabbit is not null, which means it hasn't reached the finish line, right? If it hasn't reached the finish line, right, then we want to keep going. Right, so let's check if that makes sense. Well, if rabbit hasn't reached the finish line, eventually they meet each other, right? And we eject out of our while loop, right? So we'll say while rabbit hasn't met finish line, right? What we'll do is we'll say turtle equals turtle dot next, right? And rabbit equals rabbit dot next dot next, right? But if we're doing dot next, then we're going to have to make sure that rabbit isn't at finish line, or rabbit's next step isn't finish line, right? And the reason we have to do that, right, is because we're doing dot next. So if our next step is the finish line, then dot next is going to throw an error. Now the way we actually eject from this, right, is by making certain, the way we eject from this is by checking, right, if turtle ever equals rabbit, right, then we're going to want to return false, right? If they're ever at the same position, return false, right? And if we make it to the end of this while loop, or to the finish line, if we ever make it to the finish line, we can return true, right? So now we can make these statements make sense. Rabbit isn't at the finish line, right, if rabbit dot next does not equal nil. Or actually want to do, no, I actually want it to be like this. If rabbit does not equal nil, and rabbit dot next does not equal nil. Oh wait, yeah, we can do this, and we'll say do, and then we'll say and. So we can check if this makes sense, right? Rabbit starts at 2, turtle starts at 3, right? Is 2 null, or is 2 dot next null? No. So we into the loop. Are they the same? Nope. So we do next for both. We go to -4, and turtle goes to 2, right? Now is rabbit, right, which is -4 nil, or is rabbit.next nil? Nope, right? So now we go in, we check if they're the same. -4 is not the same memory location as 2, right? So we do -4, move it twice over, right? goes to 2, goes to 0, and turtle moves 1 forward to 0. So now they're at the same location. We enter the loop. Oh no, well, we check the case, right? Is rabbit nil? No. Is rabbit.next nil? No. Are they the same? Yes. So there is a cycle. Now for this case of 1, we'll say, okay, turtle equals head, rabbit equals head.next. Now is rabbit nil? No. But is rabbit.next nil? Yes. So we'd return true. There is no cycle. Let's try it. So we actually return false. Oh, we actually have to flip it, right? Our function is called hasCycle. So if turtle equals rabbit, we want to return true, right? So this makes sense. This would work in linear time with constant space. I think another version we could do, just because of the way Ruby works, since you can use an object and a hash, we could just check if we've ever seen a value before in the hash, right? And if we have, right, then we know there's a cycle, right? But if we never do and we reach the end, there's no cycle. So that's another way to do that problem. So given assigned 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the assigned 32-bit integer range, negative 2 to 31, or 2 to 31 minus 1, then return 0. So the environment does not allow you to store 64-bit integers, signed or unsigned. If x equals 1, 2, 3, they want us to reverse it to be 3, 2, 1. Right, and retain the sign. So I think we could definitely do this. I think the way we usually go about this is treating the value as a string, right? So we just usually cast x to string, reverse string, cast reverse string to int, right? Retain sign, check bound, check if break bounds, right? I'm actually realizing I'm doing this in TypeScript, right? Like we said, cast x to string, reverse string, cast reverse string to num, retain the sign. After we retain the sign, we want to check boundaries. If break bounds, return 0. Otherwise, return reversed num. Right? That's usually how this one goes. Time complexity for this in retrospect, when was the last time we did this? A long time ago, July 2nd. Very interesting, because this would be done, right? If we can assume that this would be a 32-bit integer, you can relatively guarantee this would be constant time, constant space, just because we can guarantee that x, casting x to a string, right, is kind of relevant. Reversing the string, right? At worst case, 32-bit integer has, I think, like, I don't know how many digits, but it's probably bounded, right? Casting it is fine, retaining is fine, check boundary. So it would technically be constant time, constant space, right? We use a string that we use to hold, we hold a value, right? A string that may have, let's just say, whatever the max number of digits for a 32-bit integer is. So it's also kind of constant space. So we could do is x string equals x.toS to cast it to a string. Well, now we want to reverse it, right? I wonder if strings are mutable in Ruby. We'll find out though. So we'll say left is equal to 0, right is equal to x.length minus 1. And then to reverse the string, we're going to do a while left is less than right do, right? We're going to say temp is equal to x, and I said we want to do x dot length, we want to say x string sub right or sub left. Since we're saving x string sub left, we're actually going to replace it with x string sub right, right? And then x string sub right actually gets the value of temp. Then we do left plus equal 1, right minus equal 1, right? Then we have end to reverse the string, and then let's just print x string. So it is reversing the string. I think there's one thing to make certain, right? It's possible that our string has a negative value, right? In this case, that would actually give us a problem. So what we want to do, right? We'll say x dot toString we'll say if x is less than 0, right? What we actually want to return is x dot toString, right? But sliced until the next, to pretty much ignore the negative sign in the front. Otherwise, we'll just do x dot toS. I know there's definitely a way to slice. Or maybe you can't slice. Let me check. Okay, definitely should be possible. So we do x dot toS. Now I'm not exactly understanding why this isn't working. Maybe you can't do -1, or you can do a range. Okay, so now we're good. Right, now we want to cast our reverse string to a number. Right, and we'll say at rev is equal to x, or I think it's something like this, integer dot try convert puts rev. Okay, it's not working. Maybe you can literally just do integer x string. So it looks like you can. So we're going to say if x was less than 0, then the value we're going to give it is negative integer. Otherwise, we're going to give it integer of x string. So we're good, right? We retain the sign. Now we just have to check boundaries. So we'll say if rev is less than 2 to the negative 2 to the 31, or rev is greater than, right, 2 to the 31 minus 1, right, we want to return 0. Otherwise, we want to return rev. So something's going off here. Output is 17 when we're respective 21. So maybe let's put x string to see if something's up. std out 3, 2, 1. So this is actually interesting. I'm going to try something different. I'm going to say puts integer, right, when I pass in a string of 0 to 1. Right, so this is actually strange. I guess I expected this to automatically strip front-facing zeros, but I guess that was an assumption we made. So we're going to add a step, right, strip front zeros. And we can just do is say while x sub string dot length is greater than 0, right, and x sub string sub 0 equals like a literal 0, we're going to do, and we're going to say x sub string dot shift. Or since you can't do shift, we'll just slice it, right, with 1 going to the range -1. Oh, not slice. I think it's just right. And since that's the last thing, right, we just have to check, right, if x equals 0, right, then we have to return the reverse, which would be x. What if x only has one character? We reverse it. I think we should be fine. So I think this is fine. This seems to work. It would be constant time and constant space just because we can guarantee pretty much at max 64 operations, or I guess I don't know how many characters are included in a top and how many digits a number has when there's 32 bits, but I think we would be fine. So that was pretty cool. That was an interesting run. And then we have binary tree in order traversal. So given the root of a binary tree, return the in-order traversal of its nodes' values. So in-order traversal refers to a DFS where the relative ordering among the nodes we visit would actually be L, N, and R. And it looks like we're supposed to return this in an array of integers. So if that is the case, we can just have a function in order, right? This in order function could just take an array, right, as reference, and it'll take the root as well, and then we could return this array, right? Then we could define this in order function, right, which would take a root, or I guess a node, right, and an array, right? It would do some work. Now the work it would do is it would say if the node exists, right, then we'd like to do some work, right? And the work that would be done is this in order traversal, right? So to do in order, we want to go left first, so we'd call in order with node, left, and array, duplicate it a few more times, right? And then we'd call it with right. And the operation we're aiming for here is this array that has the value stored in order. So when we're doing n, which is the node we're currently at, we're going to want to do r.push node.val. So this would be linear time with linear space. Could we do it iteratively? Could we do it iteratively? I don't see why not. But I think we definitely haven't done something like this iteratively in a while. How do we go about doing that? How do we go about doing that? Get rid of a tree. right? What we want is to do it iteratively, right? How could we do it iteratively? With recursive functions usually translate well to stack usage, right? So we want to do this with a stack. We want to do this with a stack. So I think we could do this with a stack. So if we had a stack, which would just be an array, and I wonder if actually, we'll see if this even works. Stack.new. Not implemented, so it doesn't exist. We're going to use a stack, right? We're just going to end up using an array. So we're actually, it's still the same thing because we can pop and push onto the end of the array in constant time, right? But what's going to start in the stack would actually be root. And the goal would be, right, to do this iteratively. So in order, we want to go left as deep as we can go first, since we're going depth first. And then when we can't, right, then we want to process the node that we're currently at, and then go as far right as we can, and then repeat this process. So that lends well to a double while loop, where the first while loop will make sure that we visit all nodes that ever end up on the stack. So we'll say while stack, or while root does not equal nil, or stack.length does not equal 0, right? Then we're going to do some work. And the first thing we're going to do is enter another while loop, right? Now, I don't think we want to say root. We want to say cur. We'll set cur equal to root to start. And we'll say while cur does not equal nil, right? What we're going to do is we're going to add the current node onto the stack. So if we start at 1, right? Cur is not nil, right? So we're going to do some work. We want to go as far left as possible. Now to do that, we're going, or 1, actually don't need stack. We can actually have the stack empty. We're going to say stack.push cur, and then we're going to say cur equals cur.left to go as far left as we can first, right? And then as soon as we equal nil, we can't go left anymore, right? So now, right, we're going to want to say cur is equal to stack.pop. Now that cur is equal to stack.pop, we're actually going to have that array we had earlier, right? And then we can say, right, that r.push cur.val. Right, we don't have to worry about cur being null because we only ever push values of cur that are non-nil. So now we want to go as far right as possible as we can, right? And to do that, all you have to do is set cur equal to cur.right, I think, right? Because now we pushed 1 on, all you have to do is set cur equal to cur.right, and since cur isn't null and the stack isn't empty, we're going to go as far left as we can again. So this looks like it's going to be linear time with linear space. In the worst case, we can have n elements on the stack, which would be linear space. This is an interesting one. I wish there was a better way to do this. Something about this, the thing is, if I had to do pre-order traversal, I don't even know how I would do that. How could we do pre-order? Pre-order means we would print the node first, right? And then go left as far as possible. So maybe we would do something like we do r.push cur.val, and we do cur equals stack.pop. No, we wouldn't even do that. We'd say cur equals cur.left, right? And well, we're going to push it onto the stack. I think we'd have both these loops duplicated. And it would be that cur is equal to stack dot pop. Cur would be nil to start. So there would be a write. You can always just wrap this. We'll just say if cur dot write. Push all this over. And you can do the same thing here. I guess the main thing that we're worried about, right, is that cur actually exists. So I think we actually wouldn't have these problems if we just made sure that cur actually exists. So we'll say if cur, then we'll say end. Undefined method write. Cur equals cur dot write. Not following. Undefined method write for nil class, no method error. We'll say if cur does not equal nil. Okay, looks like not following. We do puts cur. Cur dot val. It's 1. Cur is not null. Its right subtree is null. Maybe that is actually what we need, right? So say if cur dot left does not equal null, right? Then we'll do end, right? And if cur dot right does not equal nil, this actually doesn't make sense. Given a tree 1, we push cur on, right? We push value onto the array. Now we go left. We can't go left anymore, right? We come out. It's null. I see what they're saying. Cur is just literally null.